Okay, basketball people, they don't want to say hi to you. So, this is the notes for section 5.4, which is graphing square root functions. Okay, they will sometimes refer to square root functions as a radical function. So this word that they say right there, they call it a radical function because this symbol right here is a radical symbol. Okay, like square root is a radical symbol. So square root functions or radical functions, we're just graphing things like y equals the square root of x, which looks like this when you graph it. That's the parent function. Okay, we've talked about him before, right? He starts here and he goes on forever to the right. Okay, why does he not go to the left again forever?
Because you can't have a negative.
You can't have a negative inside of a square root, okay? All right, so now that we have that stuff, let's go to, I'm going to flip back and forth between these two pages. So if you're watching this video, you're basketball people, we're going to fill out this very, very, very right column of this sheet, okay? And this is going to be kind of your cheat sheet for your homework, okay? You guys probably have like these two columns filled in also, and I don't have them up here, but we'll just leave it at that. You do have kind of these 4 columns here, have like all the information that you need to kind of cheat on this, I guess. When you're doing a vertical translation 6 units up, you are adding something to the outside of the function. That's kind of how you read this cheat sheet, okay? If I'm horizontally translating something 4 units to the left, I am adding and subtracting, but I'm doing it inside the function, okay? So we'll show what that stuff looks like, all right? What I'm going to do is to keep me from like making you dizzy and going back and forth. Will you help me? I'm going to write those things from the very left side right here. So this was, what, up 6?
Yep.
Up 6, down 5?
Yep.
Okay, what was this one?
Right a 9.
Right 9?
Left 4.
Left 4?
Vertical stretch by a factor of 5.
Vertical stretch by 5?
Vertical compression
By
by
5.
a factor of 1/3.
Vertical compression by 1/3. Don't write this stuff down. I'm just making it so that like I don't have to flip back and forth, whatever.
Horizontal
Okay.
stretch by a factor of 2.
Horizontal stretch by 2. Okay.
Horizontal compression by a factor of 1/4. And then reflection over the x-axis and reflection over the y-axis.
Over x over y. Okay. I'm just writing that down in this column because I don't want to have to flip back and forth. Okay. So we are starting with this function, and we call that our parent function. Like that's basically what you're starting with if you strip everything else away. And what he looks like, we just got done talking about that. He starts here and he goes forever to the right, okay? If you want to designate points in here, like this would be the point 0, 0, okay? The point 1, 1, okay? If I take the square, if I plug 1 in for x into this function right here, the square root of 1 is 1, right? If I go over to like 4, the square root of 4 would be 2, right? That would be the point 4, 2. The next really nice point that comes out is 9, 3. The square root of 9 is 3, okay? So those points are going to live along that curve. So if you want actual points along that curve, that's what he looks like, okay? All right, so if I'm starting with my parent function being the square root of x, I want to take this graph or this function and I want to shift him up 6 units. Okay, what will the new equation look like if I'm shifting it up 6 units? You want to take a guess?
So,
right. Now, does the 6 go underneath of the radical symbol or outside of it?
outside.
Why outside? Because outside of the function, right? Okay, that's your little cheat sheet. So it is the square root of x, stays the square root of x, but the plus 6 goes on the outside. Like that. Okay, now 5 units down should be easy from there, right? Y equals the square root of x minus 5. That's 5 units down, okay? And what that will do on the graph of it, like if I'm taking him and I'm moving him 6 units up, 1, 2, 3, 4, 5, 6, really this is what's happening to him, right? So that's 6 units up. 5 units down would be right there, like that. Make sense? Okay? 9 units to the right, okay? This is going to be just a little bit different. It's all going to be inside of the function. Usually inside of the function we use parentheses for, but your bar is getting treated like the parentheses. Okay? So the 9 is going to go underneath of the bar with the x, but when you're going to the right, right means plus, except in this case, it would be minus 9. Okay? So you guys might have on your sheet off to the side over here, you might have a little star that says use the opposite sign, right?
Yeah.
Like right actually means negative and left means positive. So what does 4 units to the left actually look like? X plus 4 underneath, right? That's what he would look like, okay? 9 units to the right would just take and make him look like that. 4 units to the left would just take and make him look like that, okay? Same thing, but just moved over, right? Whichever way, all right? Now, vertical stretching by 5, okay? What does it mean to vertically stretch something? That's kind of like saying what? It makes him taller and skinnier. Okay, I'm just going to say taller and we'll talk about skinnier here in a second. So vertically stretching is going to make him taller, right? If you take me and you vertically stretch me, please do that if you could figure out how to do that somehow. Please take me and vertically stretch me if you can figure out how to do that. Vertically stretch, make me taller, okay? By a factor of 5. So we're taking this and making it 5 taller, right? You multiply it by 5. So y equals, and when you multiply it by 5, where does the 5 go? In front of the square root, okay? The 5 can either go on the outside or it can go on the inside, but vertical stretch right here, this guy is outside the function, right? That's this column, outside of the function. So the 5 goes on the outside of the bar, okay? What about vertical compression? That makes him shorter by 1/3, and so my new function is going to look like what?
5 equals 1/3.
1/3 square root of x, yeah? Okay, if we talk about what that looks like on the graph, you don't have to graph this, don't write this down, okay? My original guy is going to look like this. If I stretch him vertically by a factor of 5, okay, what's going to happen to him is he's going to do like this, right? He's going to be taller and like skinnier, right? Taller and skinnier. If I'm making him shorter by a factor of 1/3, it's going to be like really, really kind of elongated and short. Okay, make sense? A horizontal stretch by a factor of 2. Horizontal stretch is making him fatter, right? We're making him fatter. Fatter by a factor of 2, so he's getting twice as wide as what he was before, okay? Y equals, now we have to figure out where that 2 goes, but you should also have a note off to the left side over here. You should have a note that says something. What does your note say? Use the reciprocal. Okay, what's the reciprocal of 2?
1/2.
1/2. What's the reciprocal of 4? 1/4. I just said it. 4, right? 1/4 becomes 4/1, or just 4. Okay, so instead of using 2, we're going to use 1/2. Instead of using 1/4, we're going to use 4. But where do they go? Inside the square root. So it looks like square root of what? 1/2 x. That's how he works, right? Y equals the square root of 4x. A horizontal compression is making him, like, what's this guy doing? What does it mean to horizontally compress something?
Making it taller.
Skinnier, okay? But you guys just said skinnier equals taller. For the most part, these two things kind of go together in a sense. If you're making him taller, you're making him skinnier also. If you're making him shorter, usually he's fatter, okay? All right, make sense? Okay, good. So those are going to kind of look like this, okay? Taller and skinnier, shorter and fatter. They'll kind of look the same way, okay? Over the x versus over the y, they're going to involve using a negative, okay? But it just depends on where that negative goes. So if you use your cheat sheet over here, our reflection over the x-axis, the negative goes, this column says outside. So reflection across the x-axis, the negative goes on the outside. So what's that look like? Negative square root of x, right?
Mm-hmm.
When you're going over the y-axis, the negative goes inside. So it looks like the square root of negative x. Okay, now how can you have a square root of a negative number?
It's called the
No, well, okay, you're right, except these ones won't have imaginary numbers, okay? When you go to graph this thing, okay, the only numbers that I will be allowed to plug in for x will be negative numbers, okay? Like, let's say I want to plug in a negative 2, okay? Normally, I'm not allowed to plug a negative 2 in for x right here because I can't take the square root of a negative 2. But if I plug a negative 2 in here in this spot, it will be negative 2. which will actually turn it to be positive 2. So that's why I can get away with that. Does that make sense? Okay. So for this case, you will only be plugging negative numbers in for that. Okay. I'm going to get rid of all my messy stuff. Okay. Makes sense?
Mhm.
All right. Okay, so now let's talk about what the graph is doing. So go back to your notes, but use this guy as your cheat sheet. Okay, have this guy ready to go for you. We want to go to notes. Sorry, I'm making you dizzy. This is 5, 4. No, 5, 4. Here we go. Right here. All right, example 1. Identify the domain and range of this function right here. Okay. All right, so what I would suggest that you do is to kind of sketch a little graph of what he looks like. His parent function is the square root of x, right? But then we have to decide what the 4 is doing. So how does the 4 move this function? How does the 4 move that square root? Up 4 would be this.
It's moving
It's moving it left.
Okay, it's moving him to the left 4. Okay, so I'm going to take and I'm going to do a little rough sketch over here. 1, 2, 3, 4 units to the left. That's where my dot is. And I'm going to go this way, and that's kind of what he looks like-ish. Right? Okay, this point right here where he starts is the point -4, 0. Right? That's what he looks like. Okay? All right, then, after we do our little rough sketch of what he looks like, they want us to label the domain, and they want us to label the range. Okay? All right, pay attention to this really carefully because it's kind of hard to understand, but once you've got it, you've got it. Okay? The domain is the x's, and the x's go which direction? What way do x's go?
Horizontal.
Horizontally. They go left and right. Right? Left and right. Okay, so I'm going to ask myself when I'm doing the domain, does this thing go to the left forever?
No.
Does this graph go to the left forever? No. Does it go to the right forever?
Yes.
Okay?
It's -4.
X has to be what in relationship to -4?
Greater than or equal to.
Greater than or equal to -4, right? The x's go with -4. He is only beyond, from here and beyond -4. Does that make sense? Okay? The range is the up and down values. Those are the y coordinates, up and down. Okay? Will this function go up forever? Yeah, he's going out, but he's also going up at the same time, right? So he will go up forever. Will he go down forever?
No.
No. What's the lowest that he goes?
0.
0. Y's have to be
Greater than or equal.
greater than or equal to 0. 0 is the lowest he goes because that's the y coordinate that this guy is at. Okay, so your domain is going to be associated with that point. Your range is going to be associated with this point, right? Domain, range, highest, lowest point that he goes, right? Good? Okay, this box right here, I'm going to say use the chart because this box has everything in it that we already talked about on the chart. Okay, so it's talking about horizontal translation, vertical translation, blah blah blah, all that good stuff. Okay, all right, graphing functions. Graph each function and state the domain and range. All right, so let's go ahead and plug these numbers in for this guy, x squared plus 1. Okay, before we plug this in though, this guy is my parent function, x squared. What will he look like if I graph him? Just so that we have an idea. He's going to look like a parabola. Okay, do you know what the 1 is doing? Taking that parabola and moving him up 1. Okay, so let's plug our points in. If I plug 2 in, 2 squared plus 1. I don't know why I gave you only positive number. Can I change my numbers here?
Yeah.
No.
Can I change my numbers? Let's go. These are not nice numbers. Let's go -3, -2, -1, 0, 1, 2, 3. Let's go those guys. Okay, let's do that. All right, so the first number I'm plugging in is -3, and if I take -3 and I square it, that's 9 plus 1 is 10. Okay, now I'm going to do -2. -2 squared is 4. 4 plus 1 is 5. Okay, -1, if I plug -1 in, what's -1 squared?
1.
1 plus 1? 2. Okay, if I plug 0 in, 0 squared is 0 plus 1 is 1. Okay, now if I plug 1 in, 1 squared is 1 plus 1 is 2. Okay, what's the next number going to be? 5 and then 10. You guys see how this works as a parabola, right?
Yes.
Okay, if I plot those points, -3 is at 10, which is all the way off the chart, so I'm not going to really worry about it. But -2 is at 5, -1 is at 2, then we're at 1, 2, 5, and he looks like this. He's a parabola, and just like we guessed, he's a parabola and he's up 1, right? So that's what he will look like, okay? Domain and range. Domain, range. That's the last thing that they want us to do with this guy. Domain is the x's, range is the y's. Domains go from left to right. Okay, so this graph right here, will he go to the left forever?
Yes.
Yes. Will he go to the right forever?
Yes.
Yes, he's going left and right both ways, right? He's doing like a little U and he's going left and right. So what do we put for the domain?
All real numbers.
All real numbers, that boldface R. Okay, he's going to touch everything. Left and right, he's going to touch everything. Okay, the y coordinates go up and down. Okay, will he go up forever? Yes. Will he go down forever?
No.
No. What's the lowest that he goes?
X is greater than or equal to.
Now, in this case, we have to be y's. Y's have to be greater than or equal to what? 1. He goes 1, he touches 1, and then he goes up forever, right? Okay, so that's my domain and range. Good? Happy with that?
Yep.
Okay, now let's plug this. This one's going to be a square root function. Square root function as my parent function starts here and it goes like this. That's what he looks like. Something of that nature, okay? So those numbers in there are going to do some things to him, okay? So let's start with -3, plugging -3 in. -3 plus 3 on the inside of that is 0, okay? Then I have to take the square root of 0, which is just 0. Then I take 0 times -2,
0.
which is 0. And then I take 0 minus 1,
-1.
-1. So -3 is at -1. That's a lot of stuff, okay? All right, next let's do -2.